Hello everyone, this is Rupesh and I'm watching CPNet's video series on data acquisition algorithm series, and this video is about printing the leaf nodes of a binary tree. So this is going to be a very easy topic and I'm covering this just for the sake of completeness. So if you see this, I have marked already like what are the leaf nodes. This video is sponsored by Visual Assist, the well-known productivity extension for Visual Studio and Unreal Engine 4. Visual Assist speeds up development with features like smart navigation, code inspections and suggestions, powerful refactoring commands, debug assistance and a whole lot more. Even spell checking in comments. Visual Assist is written by C++ developer for C++ developer. Start your free trial at wholetomato.com. We think you will be pleasantly surprised by what Visual Assist offers, and the small touch that turns good features into great ones. Link is given in the description field. Leaf nodes are those nodes which doesn't have left or right. Okay, so 8, 9, 6, 1 and 4 are the nodes. They don't carry left and right childs. So how do you print only these nodes? And as this is a binary tree, we have three different flavors, right? To traverse this, like pre-order, post-order and in-order, right? So we have these three sort of ways to actually traverse. So for this, it will be good if you go for pre-order traversal, meaning you do the operation the moment you reach to the node and then you go either left or right. So, and yeah, the important point is whether you want to print it in this direction or in this direction. So if you want to print it in this direction, then you have to go to the left first. So you have to go to the roots left, and then, let's suppose this is your helper function, and then you will go to helper function roots right. Okay. So if you're standing here, then you will keep going to the left and then you will reach here, right? So that's why you have to go to left first. So that's why you will reach here first, and then consecutively you will go from 8 to 9 and 6 and 1 and 4. And what make these leaf nodes leaf nodes? I already explained you, they don't have left or right child. So let's quickly see how we'll do this. So let's assume this is your helper function. We are calling this helper function and going for the left first and then right. And this is like a pre-order traversal. And you should know what is pre-order traversal. If you don't know what is pre-order traversal, you just go and search pre-order traversal in my channel. I have explained bit by bit like how it actually happens with the example of stacks and all. So it will be very easy for you to understand this. So initially you are giving this 2 here, right? So this 2 is coming here. It is not null, so it will go here. Roots left is equal to null pointer and roots right is also equal to null pointer. Then only you will print that roots value. So is this true? No, roots left is not null. So we'll execute this line now, then roots left will actually go. So this 3 will come now, and the same story will go with 3, and then 5 will come, and then 8 will come. The moment 8 comes, for 8, roots left. So 8's left is also null and 8's right is also null, right? So there is nothing inside this. So in that case, we'll print 8. So see, we have printed 8 already. And then we'll return. Returning will go from here to here back. And then we'll go from here to here. And the same story will go for this also, like 8 will actually have something in the left. Okay, so 8 is actually having something in the left. So this will not go. It will again go for the left. Left of 8 is, yes, we have some. We'll go there. So 9 will come now. And 9 is not null. 9's left and right both are null pointers. So we'll print 9. So see, we have printed 9 now. And then we'll go back. So we have went back from here to here. So meaning we are coming at this line because we went from 8 to 9 because of this line, because we went roots left. Now you are coming back. If you are saying return here, so when you're coming back, you will reach exactly to this line number, right? And then you have to execute this one. This is how you return from some function, correct? So if you return from some function, you will execute the next line. So the next line is helpers roots right. So you will try to call yourself with roots right, which is actually a null pointer. We don't have anything here. So null pointer will go here. It will see if it is null pointer, then it will return from here. So we are returning from here also. So as we are done from this whole part, we'll go back from here to here now. And see, you would have gone from here to here and this whole story would have started just because you went from here to here. And you can only go from some node to left just because of this roots left line. Now if you are coming back, So you have to assume it like this. If you're coming back, meaning you are hitting this line only. So what is left? This line. You have to still go to the right. So you will go right from here to now, and then you will reach 6. So once you are reaching, you're sending 6 from here to here, you will see, okay, 6 left is null pointer and 6 right is also null pointer. Then you will print 6. So let's see, we are printing 6 here then. And after that we'll return from here. See, we are returning. So we'll go back from here to here. Now see, you are done visiting all the nodes of this tree because you are coming back. You are going back from here to here. So you have already visited left and the right. Now you will go back because this function stack is over. You have already hit this curly braces. Okay. You already executed the right one. Left first and then right. So you are done. Now you're going back. Now you'll go from here to here. And the same story goes. We'll check if roots left is equal to null pointer. Yes, it is. But roots right is also null pointer. Then only it is leaf. But in this case, roots, which is this node right now, is having the value. So in that case, we'll not print it. We'll try to go to the roots left, which is actually null pointer. We will actually send this null pointer here and it will be recognized here. It will go back. Then we'll try to send roots right, which is this 7 now. And then it will not be true for 7, obviously, because 7 is not leaf node. Then we'll try to push 7's left here, which is 1. And then for this it will be true because 1's left and right both are null pointer. So it will print 1. We'll go back from here because there is nothing. We have already returned from here. Then you'll try to go to right because you went to this place because of this left, right? Now you'll come back and try to execute this roots right line. Okay. So in this case, you'll go to this place. So this will also be true because 4's left and right childs are null. So you ended up printing this one. Now this is very easy. If you don't know this, meaning you are a very beginner. And I want to give you a question. See, what I asked was print the leaf nodes of a binary tree. So we have successfully printed this 8, 9, 6, 1, 4. Now you printed this in this order. Now what if you want to print it in this order? Just pause the video and think about it. And I'm going to give you answer now, because if you are looking for the answer, you will just swap these two lines, this line and this line. If you will swap it, instead of going to the left, it will start going to the right first. So in that case, it will hit this 4 first. So then you will have this 4 here, and then you will go back because you are done with this whole thing. And then you will try to go to the left. Then you will hit 1. So see, you are going backwards now. See, so it is like 4, 1, and then next what you want is 6, right? So 4, 1, and 6. That's how it will be backward, right? So see, once you are done with this, because this 7 is also not a leaf node, this will not hold true, this condition. You'll go back from here to here, here to here, and then you will try to go to left, because see, initially you went in the right direction, right? Because you have swapped these two lines. So you started going to the right. Now you are back. So you have to go to the left, because for this node, left is actually remaining. So you'll go from here to here. So the moment you reach to 3, you will try to go to right, because we have swapped these values. So right will come first. So you'll go here, and then this 6 will get printed, because for 6, this value will, this condition will be true. Okay. So likewise from 6, now from here, you will go back. Then you go back from here to here. You will travel from here to here. And then you will go to right, because you are going right now. And then you will try again going right, but there is nothing. So you'll go to left, and then you will print 9. So see, you're printing 9 here. And then after that, you will print 8. So see, it is exactly reverse of this. It was easy, right? Yeah, I know that. So thanks for watching, guys. Bye-bye. Take care.